Hello, in this video I'm going to talk about how you can hopefully increase your score in ACT science by familiarizing yourself with some of the terminology that's used in ACT science exam. In ACT science exam, they don't measure how much you know biology, chemistry, physics, earth science. They want to measure how much you think like a scientist, how much you reason out like a scientist, and how much you are able to extract information from data in forms of tables and graphs. So before going any further, let me go over some basic terminology that a scientist uses when she does an experiment. When a scientist does an experiment, she measures how one variable affects her experimental variable. So the variable the experimenter, the scientist is measuring is called the dependent variable. The dependent variable always goes on the y-axis. And then how one variable, how one condition affects her experimental variable, that other variable is called the independent variable. The variable the experimenter manipulates, and that goes on the x-axis. So let me show you how this goes. So if this is a hypothetical graph, the independent variable, the variable the experimenter manipulates, goes on the x-axis, and the variable she is measuring goes on the y-axis, and is called the dependent variable. Let me give you a hypothetical example of how this terminology is used. Suppose you want to measure how much caffeine affects your metabolism. So the different concentrations of caffeine, let's say 1 cup, 2 cups, goes on the x-axis, and the different concentrations of caffeine is considered the independent variable. So 1 cup, 2 cup goes on the x-axis. And to measure the effects of how much it affects your metabolism, let's say you measure how many times you breathe in per minute. That's the variable you are measuring, and that's the dependent variable. That goes on the y-axis. How many times you breathe in per minute goes on the y-axis. Before going any further, let me go over another terminology scientists use when they do an experiment. Whenever a scientist does an experiment, she always runs a control alongside the experiment. Control is a set of variables that's exactly like the experimental variable, except for the manipulated variable. So going back to our caffeine experiment or caffeine research, the subject without consuming any caffeine would be the control. So all the other variables are going to be the same. The amount of liquid the subject takes, the amount of food she had before consuming caffeine, everything else is going to be the same. And the control would be the subject without consuming caffeine. So in this way, the scientist can compare her data to see if truly the amount of caffeine affects her breathing rate. Okay, let's go over some type of graphs. Let's go over how to interpret data from different types of graphs. And I'm going to begin with showing you how to interpret data from line graphs. So line graphs are the best types of graph to show relationship between two variables. So as you see on the top graph, this shows the relationship between your independent and dependent variable. As the top one shows a straight line going upward, and that means that as your independent variable that's plotted on the x-axis, as the independent variable is increasing, so is your dependent variable. So your independent and dependent variables are directly related in the top graph. The middle graph here shows that as your independent variable is increasing, the values on the x-axis, as the values on the x-axis are increasing, your dependent variable is decreasing. You see these values are lower. So the relationship between your dependent variable and independent variable are inversely related. Your variables are inversely related. And on the bottom graph, it shows that as the independent variable is increasing. As your x values are increasing, your y value is staying the same. So this means that your dependent variable and independent variable are not related. They are unrelated. They are not related to each other at all. The same goes with if this line was a straight line going to the x-axis. That meant that as the y values, your dependent values increase, your independent variable stays the same. Either a horizontal line or vertical line indicates that your variables are not related, they are unrelated. Now let me go over a typical ACT type question that deals with line graph. In this graph here, they have plotted equivalent concentration of carbon dioxide on the y-axis, and on the x-axis this is the year, the time where they took the measurements of carbon dioxide concentration. And these are different sectors: electricity generation, transportation. And the question is asking you which sectors' greenhouse gas emissions have declined since 1997. So the first thing you to do, you're going to locate your 1997 time frame, which is this set of data points. And from 1997 on, past 1997, what is the trend you see on your data point? You see this is almost unchanged, these are almost unchanged, this is slightly increasing, this is slightly increasing. The only one that has declined is this one, which is the industrial sector. So the answer to this question, which sectors' greenhouse emissions have declined since 1997, you look across and your industrial sector, the carbon dioxide emission has declined. Another typical ACT type question is extrapolation. On this graph, they have plotted eye irritation. I would suppose eye irritation is measured as how many times you rub your eyes per minute. Eye irritation in arbitrary units, and the x-axis is oxidant concentration, and they have compared the different oxidant concentrations on these graphs. And question number 5, it says if the oxidant level at station 5 is this set of data. If the oxidant level at station 5 rose to 4D, I suggest that on ACT science exam you take a small ruler with you to the test, because on these extrapolation type of questions you need to draw a straight line and extend your data point, and that's what I did with the orange line. I extended it until it reached 4D point, and then I went across to the y-axis. And if this is 50, this is 60, you see this is slightly above 50. So the best answer would be 53. Let me go over another type of graph that's commonly seen in ACT science, and that's the scatter plot. I have a typical ACT science question here, and it shows concentration of carbon dioxide taken at different time of the year. And scatter plots consist of large data points. There are a bunch of points that represent a data point on the graph. And if your data point go from the origin to high x and y axis, this means your variables are positively correlated. Scatter plot is used to show correlation between variables. And if they go from high y-axis to high x-axis, this means that the variables are negatively correlated. So in this question it says which area shows the most positive correlation between time and carbon dioxide. As you see, the data points are different shapes, so they were taken at 3 different areas in the United States: Alaska, Hawaii, and South Pole. So they are not all United States, just different locations. And you see these data points between January and almost May, you see the most positive correlation between the data points. And these data points were taken in Hawaii. So the concentration of carbon dioxide has gone up during these months of the year. Probably photosynthesis was not as effective. That's why concentration of carbon dioxide has gone up. But it says which area shows the most positive correlation between time and carbon dioxide concentration. And this is the area where you see the most positive correlation. Another type of graph that's commonly seen in ACT science is bar graph. Bar graph is good when you are comparing set of data, and the height of the bar graph shows the concentration or shows the amount of the dependent variable. So you see in here again they are comparing the concentration of carbon dioxide at different sectors, and as you see the height of this bar graph shows the concentration of carbon dioxide. And the question is asking what sector's greenhouse gas emissions saw the highest percent increase between 1995 and 2000. And you see the difference between the height of these graphs are all very small, but the last one, electricity generation, the height of the graph, the difference is significant. So the answer to this question, what sector greenhouse emissions saw the highest percent increase between 1995 and 2000, the answer is electricity generation. These were a few examples of ACT science type questions, and I hope that you found them helpful. Have a good day. Bye.